All right, we're back.
Okay, hello everyone. Welcome to day 2. We had a short flyover tour this morning. I hope those of you who attended it had a great time. And if you missed it, please make sure to come to the Tour of Canada tomorrow at 8:30 at the same time. So I hope you had a great time yesterday. There were lots of interesting presentations and discussions shared. And today is promising to be a very exciting one with a lot of presentations and plenaries. And the highlight of the day is the luncheon keynote speech by Carrie Watson. So please make sure to be there. So we're starting Plenary 4 now. So Plenary 4 is going to take you on a different kind of tour. We're going to shine a spotlight on a number of centers of excellence in transit data applications from around the world. We have 7 presentations giving us overview of 7 research centers from Japan, Australia, the US, Europe, Canada, and South America. So all of those centers have been really at the forefront of research in transit data applications to planning and operations and management of transit systems. They have made very significant contributions to the research community and also to industry. They all share in common a very unique arrangement and setup of collaboration and partnership with industry partners. So not only do they produce very high quality research, but they also work very closely with transit agencies and in a way to facilitate really the transfer of any new knowledge or technology to be put in practice. Which is something that's really very interesting and something to learn from by other centers. So I'm not going to take up a lot of time. It's we have 1 hour and 45 minutes with 7 presentations, as I mentioned. Each one of them will be roughly about 12 minutes or so, more or less. I'm not going to take questions after each presentation, but we will leave that to the end. So without any further ado, I'm going to invite the team from Australia, Mark Hickman. Please, you can share your screen now, Mark.
Okay, I hope you can see my screen now and hear me speak.
Yes, we can see your screen.
I have a slightly slow internet connection, so I apologize in advance.
Okay.
Appreciate the conference so far. I've really enjoyed participating in day 1 and am really grateful for the opportunity to talk a little bit about some of the things that we are doing here at the University of Queensland in Australia. I wouldn't get very far with our work here at the University of Queensland without something called the Transport Academic Partnership. This is a joint agreement between our State Department of Transportation, or the Queensland Department of Transport and Main Roads, the Motor Accident Insurance Commission of Queensland, and 3 universities here in Brisbane: Griffith University, Queensland University of Technology, and the University of Queensland. Together, we have a collaborative research program together that is jointly funded by both the State Department of Transport, or TMR, and the universities to do joint research between the universities and the State Department of Transport. And that's a really important partnership that we think is somewhat unique, at least in the world, or at least certainly within Australia. And it allows us to do a lot of research directly with people at our State Department of Transport. It's important also to note that our public transport authority in Queensland is also a statewide organization. It also falls under the Department of Transport and Main Roads. And so when we talk about doing public transport research, it actually goes beyond just simply work that we're doing in the city of Brisbane, but across the entire state. We're also supported internally at the University of Queensland by strategic funds set aside by our Vice Chancellor. That's the equivalent of a president of a university in other parts of the world. The Vice Chancellor has graciously given us a significant amount of strategic funding to support joint transport and population research work that's going on within the entire university. So it's interdisciplinary work that goes beyond just simply what we're doing in transport and civil engineering, but includes our Population Research Center, which is run out of the School of Geography, the School of Civil Engineering, and then we also have a number of collaborators in the School of Information Technology and Electrical Engineering, primarily in the areas of sensor technologies as well as big data analysis. The key people as part of our team here include Dr. Juan Kim, who's a senior lecturer here at the University of Queensland, and Dr. Kelly Bertolacini, who has recently left from a postdoc under me to work at Griffith University as a lecturer there in civil engineering. I might also mention that a lot of my work that I've been doing in the area of public transport and big data has really been supported by a cluster of PhD students who worked with me in my previous life in the United States at the University of Arizona. Dr. Neiman Nasir, who was a postdoc with me briefly at the University of Queensland, but is now at the University of Melbourne as a lecturer. Dr. Ali Rezakani, who's now an assistant professor at the University of Minnesota. Dr. Sengdu Lee at the Denver Regional Council of Governments in the U.S. And Dr. Hyunsu No, who's also at the PIMA Association of Governments in Tucson, Arizona. These represent people who are really, I have the opportunity to work with, and it's a real pleasure to have had the privilege of working with them as they sort of dragged me along into this world of big data and public transport. Here in Southeast Queensland, we have the usual set of data. We have GTFS. We were a little late in Southeast Queensland in the Brisbane metropolitan area of coming to the GTFS game, but having done that in 2013, but have generally had quite a significant feed going since then. We also, at the same time as we started GTFS, we went directly to GTFS real time. So that data on vehicle monitoring, train monitoring, and even ferry monitoring has been in place since 2013. We get reports from buses and trains roughly every 10 seconds over our GTFS real time. And as many of you may be aware, we have our electronic fare collection system, the Go card, which has transactions where we've received tranches of that data on a somewhat intermittent basis since 2013. That data set includes essentially about 700,000 trip legs per day, closer to about 580, or 590,000 journeys per day. Trip legs are just break the journeys into individual trip legs. The Go card data is fairly unique in that we do get tap on and tap off information. So we get a stop location for boarding and alighting. We get a timestamp for boarding and alighting. We also have a consistently hashed Go card ID. So we don't see the original Go card ID, but it's hashed consistently so that you can see the same card being used multiple days, multiple times per day when it is used. Along with that, in the Go card data, we also have route information, directional information, the bus identification number, and the run ID so that we know actually which run the bus was on when the person boarded and alighted. and our go-card data represents about 90% of all fare transactions. That's because the go-card offers a 30% discount on fares versus cash fares, and as a result, most people who do travel by public transport use the go-card. Only about 30% of our cards are actually registered, meaning that the people have actually signed up with personal information so that their card could be automatically topped up or other things like that. The nice thing about the go-card data is that we do have that at the individual level, and it really provides quite an excellent resource for analyzing customer activities. In addition, because we work directly with the State Department of Transport, we also have quite a lot of additional transport data. Perhaps the most useful in many respects for understanding travel times and operating speeds would be Bluetooth readers that we have at all signal-controlled networks, signal-controlled intersections in our local and state road networks. So you can see in the picture on the right, that shows essentially where all of our Bluetooth detectors are. It's quite an extensive network of those, so we can actually look at travel times in our network at the level of individual road segments. We also have extensive data from route detectors, both on the state road network and on our local road network. That information is collected every 1 minute and is available to us on a real-time basis. The kind of projects that we're working on at the moment, the first one I'll mention here is modeling objective and subjective public transport performance. We have a separate talk. My student, Lin will be giving a presentation in the next section having to do with this particular project. But what we were able to discover is that our public transport authority, TransLink, the other TransLink, runs a customer experience survey, and they ask about specific trips that were taken by the passengers. So they ask specifically about a trip on a given day. They say which route it was on, what time of the day it was taken, and they ask about their satisfaction with that particular trip. Because we have the go-card data, we can actually directly connect the survey experience from the passengers reporting with their actual experience during that trip. And from there, we can actually look at the extent to which the trip metrics that we observe objectively from the go-card data and different GTFS real-time information actually matches, or how well that matches or supports the kind of satisfaction that the customers are actually experiencing. And Jianhui's presentation will talk a little bit more about that in the next session. That's really quite an interesting opportunity to actually make direct connections of the objective performance and how that's measured in passenger satisfaction. We also have another project that we've been working on to explore accessibility using actual GTFS real-time information. Instead of just using the GTFS data, we actually get information from real-time to see, based on actual day-to-day performance, how accessibility varies. You'll see in the map on the right, it may look like one giant color blur here, but the yellow colors indicate that more or less the service is running on time, and the access is, as you might expect, with the traditional GTFS measures of access. When you get out to the darker green colors and the blue colors, that's actually where we're running significantly behind schedule, where there are significant differences between how far you can get in a particular amount of time under the GTFS and the scheduled service versus what you actually experience in reality. And it's very interesting to note that, perhaps maybe not unexpectedly, as you get further and further from the center of Brisbane, which is in the center of that giant colored map there, you do see worse service reliability, and that has its influence on accessibility. The third area that we're working in is actually correlating the different mobility data sources that we have, taking advantage of route detector data, Bluetooth data, the go-card data that we have, and the GTFS real-time data to do better understanding of multimodal travel behavior across the greater Brisbane area, looking at the ways in which people are traveling by any mode within the broader Brisbane area. We have a very large project actually that was built off of our TAP partnership with the Queensland Department of Transport and Main Roads, looking at how you try and integrate those different data sources. And finally, one of the projects that we've been working on more recently is looking at bus performance in mixed traffic. In Brisbane, all of our bus operators are under contract to translate. Their contract areas are defined by geographic area, and they sometimes include routes that appear on arterials or even on freeways, and some other routes travel on local streets. We even have a busway, an extensive busway network here in Brisbane. What's interesting is that all of the services have the same standard for on-time performance. So if you're operating in a major arterial corridor, your expectations for on-time performance are the same as if you were traveling on the busway or in a local street network where you're unlikely to see a lot of congestion. What we're trying to do is compare what we actually see from the traffic perspective, from the traditional car and truck operations on many of the major arterials and where that congestion occurs, to better understand why buses are not performing perhaps in their on-time running as the same as you might expect them to. The goal ultimately is to try and look at whether, based on the way we lay out our bus routes, whether we can have a better understanding of what routes are likely to have what sort of performance metrics in terms of being on time based on the level of roadway congestion they're likely to experience on the given roadways.
Ding.
And with that, I've reached the end of my presentation. I'm happy to talk about any number of different projects that we're working on, but that was just to give you a quick overview of the kind of things that we're working on.
Thank you so much, Mark. Very exciting and interesting work. So I'd like to invite now Jan-Dirk to share his screen. Jan-Dirk, you can, yeah.
Okay. Yeah. Can you see now?
Yeah, we can see it.
Okay, great. So good morning, or rather good evening from Japan. Thank you to you already for organizing this. Yes, it's been really excellent so far. It's nice to be virtually in Canada. I think after the 3 days, we think that might be real as a jet lag. So we might be attending from this side of the world. Okay, I'm going to talk about the research collaboration with Shizutetsu. And that is, compared to what Mark just told, it's a smaller collaboration. Well, it's here with 2 universities. It's smaller in terms of the group, in terms of the network, but much more long-standing. So those who have attended several of the transit data conferences, I think at all 6 of them we had presentations in collaboration with Shizutetsu. Okay, Shizutetsu is the local transport operator in Shizuoka City. Shizuoka City is located between Tokyo and Nagoya. There is the Shinkansen line. Shizuoka is a kind of mid-sized city, population of 700,000 people. It's the regional center, fairly independent city there. And Shizutetsu is providing the local transport in terms of buses and in terms of rail. But before I come to that in a bit more detail, very important to point out, and also for this collaboration, is that Shizutetsu is a much larger, or has other businesses as well. In total, there are, I think, 37 businesses. Oh, I should mention in this on this panel, there's also here Toshiyuki Nakamura from Nagoya University, who's really key to this, as you will see in the next slide. Also for questions later, he will also be able to answer some of these. Okay, so 37 businesses. I mentioned here some of these businesses of Shizutetsu. So besides the local bus, the local rail, there's a state agent, there's a shopping mall, there's supermarkets operated by Shizutetsu. There's building management and other side businesses that all under the Shizutetsu group. If you look at the transport network, there is so in the main rail line here. This is operated by Japan Rail. So the rail line operated by Shizuoka, by Shizutetsu, there's only one line here. It's the blue line. The main network is the bus network. It's all of the pink lines here. And again, the important point for us is Shizutetsu is the only bus operator in the city. Yeah, I mentioned the shopping mall, and so there is really a central point in the city, which is the Shin-Shizuoka station, which is the terminal of the rail line, where there's also the bus terminal, where not all but a lot of the buses terminate, and it's also where the shopping mall is located. So how does this collaboration originate? We have to mention here again, so my colleague Toshiyuki Nakamura, he was working at that time, so he's now working at Nagoya. Before he was at Kyoto, and before that he was working for the National Research Institute. And at that time there was his initiative to facilitate the usage of transit data for academic purposes, and that was in 2011. And as part of this, there was a survey among the public transport operators in the country. So again, for those who are not familiar with Japan, Japan has a lot of different operators, a lot of different private operators, besides a few large, JR is the main public operator. And the question was about data usage and motivation to use the, at that time, fastly increasing spread of smart card data. And Shizutetsu was really the operator with the most positive response, who were really keen on, despite being fairly small in network, to think we want to use these data further. I want to show you one slide here. That was actually presented at the first transit data workshop in Japan by Toshiyuki. This is some of the survey results on how the operators in 2011 saw the usage of especially smart card data. And then the point that struck was that, okay, there was a lot of very basic usage, such as, well, we want to catch the number of passengers, we want to improve the transportation service, balance of payment, but very little focus on advanced analysis. And I think that's something that yesterday morning also came out in the talk with Amer, in the talk with Brendan and Nigel, on how this has evolved over time, that the data have been used more for analytics purposes. So going once more back, so Shizutetsu was quite early, very keen on using these data for advanced analytics, and really one trigger for them also was that these Luluka is the name of the smart card system in Shizuoka, was introduced in late 2011, and soon after, therefore also in 2012, this collaboration with us at Kyoto University started. So I want to focus a bit more why this collaboration has been established, and what are these facilitators, why exactly Shizutetsu. I think, as I mentioned, one point is that Shizutetsu has a monopoly in the city. So there is, I think it's fair to say there's therefore less fear of analysis potentially helping competitors. Secondly, as I was mentioned, it's a private operator with multiple businesses and a very powerful data set due to this Luluka system. So Luluka can be used not only for the transport system, but also for shopping in these various other businesses that Shizutetsu owns. Thirdly, compared to large operators, it's probably fair to say that Shizutetsu is small, and there is less in-house analysis capabilities. So therefore, also probably making it easier to say, well, we want the collaboration of universities to help us to really utilize these data. Furthermore, there is an established monitor group in the city. So this monitor group is a group of people who have agreed to participate regularly in a number of surveys and to to have their behavior being observed and to respond to changes that she said is trying. So this was something we could also tap in our collaboration. And then on the side, I also might want to mention here, I mean, this is not, to some countries, I think it's quite different, but I think maybe in this international conference, this might be worth pointing out that I think, especially at Japanese national universities, we have some factors that I think facilitate this collaboration. Funding in terms of person costs is not very much done in the university here. So our grants that we usually apply for example, national grants also include much less personal cost. So students are expected to be either privately financed or to have their national scholarship. So it's not dependent on specific projects. And then master students, the master degree takes 2 years, and there's really 1 year where students focus on research. And we also realize that actually a lot of the research that we've been doing is with master students. So what have been the content of collaboration? I just want to mention here how the collaboration is going and just mention a few key projects. So we firstly usually have the joint discussion on problems to be analyzed. And then really the key for us is data sharing. So we have this smart card data since 2012. So there is really this long time series of smart card data as well as of AVL data that we can use for analysis. And then for a subgroup of these users, there's even socio-demographic information available. That are those people who have registered and who are actually using the credit card type of the Lulu card system. But of course, with those data, there is a strict confidentiality issue that we have to where we have to work very closely with U.S.A on that. And then the ability to conduct targeted surveys among monitor groups, and we can do so besides the data analysis, we could do surveys. And thirdly, one part of this collaboration has been a joint experiment on actually changing the point structure. So this Luluca, you can collect points, especially if you go shopping and use the public transport of the company. You earn, well, we might call it an urban mileage system, as we called it in the research. And we could change the point structure. So just to list here some of the completed and ongoing studies. So we looked at home to bus stop distance effects, especially for those people where we had some socio-demographic information, so we could understand sensitivity between distance from home address to the bus stop. And sorry. Yeah.
It's the 2 minute.
Okay, I hurry up. Yes, it's only 2 more slides. We looked at timetable changes and bus choice. So the timetables were regularly changed and see how it affected the choice. I mentioned these urban mileage systems. Silver pass and life quality of older persons has been a key topic. So then we use data analysis and the survey among the persons. And as well as since there are these data now since 2012, we can look at over time as a longer term change in behavior. We also can use the data, and I think this is now one of the benefits for us is for other studies. So for example, yesterday there was a presentation for us where we could use the data actually for more academic purposes. So the other studies were clearly very straight away in collaboration with U.S.A, but under agreement we can use them also for wider purposes. So this slide, this is my last slide, but I really want to highlight what we think firstly are the benefits of this collaboration to U.S.A. Firstly, I think there are some tangible impacts. The most important one is, or the most or the one that can be observed is the change in the point system, as I mentioned. I think our analysis had some influence on the timetable design. But then besides that, there's a number of other benefits that I want to point out. I think the data analysis, and this was what Toshiyuki told me, really helped Shizutetsu now to apply for larger projects, such as ongoing big national grants on Mars and Smart City. Awareness of value of data has been shaped. So Shizutetsu has been creating this data bank. Staff education. So 2 of the Shizutetsu staff have been enrolling in Kyoto for degrees. And I think there's been the international perspective, and I would say for Shizutetsu, it's all been for very low cost. Okay, I think I conclude here. I put here some of the papers, but that kind of was, so this is then the academic benefit for us, but I leave it at this. Thank you.
Thank you very much, Jan-Dirk. This is a very interesting collaboration and arrangement. I'm sure I have a few questions, but I'll leave those to the end. So next in line is Oded Katz from Delft University. Oded?
Yes, there we go. All right, should we share it now, right?
Yeah, looks good.
Yeah, great. All right, hello everyone from the Netherlands, Oded Katz here. So first, thanks Amer and Brendan for putting all this program together, especially this session, which I think is a nice opportunity to share not only what we do, but also how we do things in the same spirit as Jan-Dirk just did. So we'll go through some overview of the lab activities, how it has been set up, and then give some examples of the kind of things we do and how we particularly collaborate with the public transport sector. So I'm leading this lab together with Niels van Oort, who is on vacation these days. And we are based in Delft, TU Delft, and more specifically in the civil engineering faculty, where obviously we have a great focus on infrastructure, but I think it's reflected in the group activities that we view public transport as much more than just infrastructure. So this is the spectrum of disciplines, if you wish, that contribute to public transport science, which is a field of application. We by no means cover all of which, but we do collaborate with partners in other faculties and also beyond the university, of course, and also include some of these competence also in-house through the background of different team members. More specifically, we think it's fair to say cover mostly network modeling, operations, resource allocation, and behavioral aspects in our research work. From network design, network modeling, applications of complex network theory to public transport, into more scheduling problems, managing disruptions, and getting insights from behavior about mode, route choice, impact of information, reliability in particular. And oftentimes trying to put all these together in simulation models or in assignment models. So I think it's the lab grew over time quite organically, with more projects coming in, more people joining, more collaborations. And then we realized about, I think 2 years ago by now, Niels and I, that, well, we have a lab there working in public transport, and officially launched in November 2018. You can see here members of the team back then on the stage in the official launch. And here also the current group. Predominantly consisting of PhD and postdoc researchers working in different projects, national, European, and industry-based, with the support of faculty staff. And in addition, there are about 15 to 20 master students doing their thesis on public transport-related topics every year. There's a bit about us, and if you also read through our vision, you can see that from the outset, we look into the sequence of decision-making process in public transport, from strategic planning to operations to real-time management. This also has consequences, of course, for the kind of stakeholders that we engage with, from cities, officials to PTAs, to public transport companies, but also looking beyond that into shared mobility providers, software providers, and consultancies. And in doing so, we are very clear about our mission, which we are based in the university. The scientific passion that we have, but also very clear about having been interested in having practical relevance and impacts. And that means that we are constantly engaged with stakeholders throughout the process. Here's an example of the main key players that we work with in the lab. You can see public transport planning authorities, operators, cities, and research institutes, and mostly in the Netherlands, but also beyond in France, in Washington, DC, in Stockholm. And those of the upper part of the slide are those with whom we work on project base or have series of initiatives, and those of the lower part are strategic partners with whom we have more structured relationships. And the way we work together also evolves over time. So there is sort of a life cycle, if you wish, of these kind of projects. And the role that we take as researchers varies throughout the cycle. And the same goes for authorities and operators. So this is just a sketch, and obviously not all projects by all means go through this entire process. And there are also some feedback loops there. But the idea is that we first work together with authorities and operators to identify problems of direct relevance for them, which are also research problems that we can tackle. And in this stage, we all have to be quite heavily involved. Then this moves into mostly us working on coming up with solutions, but still in consultation with stakeholders, testing different things, developing models, analyzing data. Then having some phase of field trial, where sometimes also data collection may take place. And of course, there we need those that have access to collect such data. Moving forward into the analysis of field trial data, potentially refining our proposals, and if all goes well, also moving forward to implementation, and in the long run, also fading out in terms of our involvement and this becoming a state of practice. So we have gone through this process several times. Some examples that I would like to share here are from strategic planning to real-time management. You can see at the bottom left. This is a network design project with a series of stakeholders in the Amsterdam area, which are looking into how one can integrate metro and the national train into a single network, and what would be the potential line frequencies, line configuration to start with, stopping patterns. So we have been looking into this problem together, and an example in the middle that you see is with partners in Luxembourg, which that's more on the corridor management and the tactical level, schedule synchronization. And with partners in The Hague, we worked on more real-time transfer synchronization between different services. And these examples, which are more on the network analysis side, they leverage on different data sets that we have access to. And not only data, but also extracting behavioral insights from this data. So in this case, data for smart cards from The Hague, where we have tap in, tap out, and we have estimated the route choice model, and we're able to quantify the impact of crowding on passengers' route choice. And then these kind of insights can then be integrated into any further network design, schedule planning, vehicle layout, procurement decisions. Some examples of ongoing projects ranging from the redesign of a bus network in The Hague to providing real-time crowding information, how to generate such information, how would it impact route choice, also with colleagues in Krakow. Looking into potential for ride sharing in Amsterdam, and the impact of accessibility of Uber on accessibility in different cities, as well as estimating passenger delays in the metro of Woomera in Washington, DC. So those are some of the examples of ongoing work, and in these projects we're in different phases in terms of, if you look into this life cycle I've shown before. And what I would like to highlight is that this process is not a single kind of interaction, it's a whole process where we go through, if it's brainstorming, idea generation with relevant parties, workshops, sometimes public engagement events, press releases if relevant, publications in professional magazines, offering training to professionals. So we're all different means of being engaged and relevant for the industry beyond the lifetime of the project as well. So thank you for the opportunity to share this, and looking forward to discussing more after this. Thank you.
Thanks a lot, Oded. Obviously, there's so much going on at TU Delft. Thanks for sharing this information and insights.
Pleasure.
Okay, next in line is, I believe, Marcela.
Okay.
Marcela, you can share your screen. Yeah. Perfect.
Okay, is it working now?
Yes, it's working. Yeah, you can go ahead, Marcela.
Well, thank you very much. Thanks for the invitation to present here. We will make a joint presentation with my colleague Juan Carlos Muñoz from the Católica University. We put the title Successful Collaboration Between Universities and Public Transport Authority in Santiago, Chile. We have been working with the Transit Authority for over 10 years now. So we will tell you a little bit about it. We are from different universities. I am from Universidad de Chile and Juan Carlos is from the Católica University. We also both belong to advanced research centers. I am from the Complex Engineering Systems at Universidad de Chile and Juan Carlos is in CEDEUS. But you will see how this fits. Our aim, I would say, for both groups and for both universities is to develop tools that would allow using the information available for the benefit of our cities and citizens. Here is some context data. We are in Santiago, which is a city of over 7 million inhabitants. The public transport system moves over 3 million passengers per day, 22 million trips per week. One characteristic of our system is that the only payment method in Santiago is the smart card VIP card. Our system has over 11,000 bus stops. It contains a large bus system with over 300 transit lines in both directions, so 600 line direction. It also contains 7 metro lines and 1 train line, all integrated. The buses cover nearly 3,000 kilometers of roads, and we have 70 kilometers of transit dedicated infrastructure, bus lanes or busways. The data we process is the data we obtain is GPS data. All buses, all the over 6,000 buses are equipped with a GPS system that sends a signal every 30 seconds. We receive between 80 and 100 million records per week. We also have all the detailed information of the BIP transactions, which is between 35 and 40 million records per week in normal times, not these days. And we also have, of course, information about the route path, route assignment, position of bus stops, metro stations, and bus stations. So we do some basic processing with some method we have developed years ago in collaboration with some colleagues. One basic processing is the estimation of the alighting stop, which we do with methodology published some time ago. We also identify and differentiate trip from trip stages. With this, we obtain detailed information of origin, destination, travel time, bus speed, and tools for monitoring, planning, and modeling. I will show you some examples. We have very detailed information of bus speeds because with the frequent GPS signal of all buses at day, night, they are always observed. We can build origin destination matrices differentiated by type of user, by period of time, any variable you would like to differentiate by. We also can build many indicators. All these are now implemented in a platform that is available for the Public Transport Authority, but also for the operators. where they can choose the period of time they want to see, and also the variables, like for example, travel time, load profiles of bus services by stop, detailed information about the bus trajectory to observe, for example, bus bunching, speeds, and also global indicators of the system, such as the total number of trips, the average travel time, the average number of trip stages per trip, average length, etc. And these days, when we began, we used to process like 1 week of data per year. Now we are able to process data every day, and we can, for example, monitor the effect of the pandemic in the public transport validations. Here is some graph on how different are the validations in a week during the pandemic, where we have been subject to quarantine, compared to a similar week in the previous year, 2019. And this is, of course, the aggregate data, but we can also have very disaggregate data for modeling. And we have been doing some interesting analysis there of how the pandemic affects differently people from different neighborhoods. Now, what are the uses of this data? Well, this data has been used for service design by the Transit Authority, for system evaluation, for infrastructure decision, operational interventions. Actually, Juan Carlos will show some of them, and which is more interesting for me, also for modeling. And I am presenting this afternoon one specific work of modeling, of model developed with this data. I will now pass this on to Juan Carlos. We can't hear you, Juan Carlos.
Thank you very much, Marcela, for this first half of our talk. And thanks for all the organizers for taking the courageous decision of organizing the first, at least, international conference I participated that is fully online. I think it has been so far great. The introduction that Marcela has given to the system of the public transport system of Santiago puts me in very good position to tell you a little bit of how we have used the information developed by Marcela's team to improve the system that the public transport system of Santiago. Let me see, I think I'm moving in the wrong directions. So we in the Catholic University and the Center of Sustainable Urban Development have been working with the same transit authority, or we worked really, we haven't been working in the last years, but if we worked with them in 4 different areas. In try to monitor the system, try to identify operational improvements, help them develop better contracts, and develop some new methodologies to understand and how the system could be improved more systematically. And today I'm going to be telling you about the first 2 where we used a lot of transit data. First in a methodology to identify bottlenecks on the bus systems, and then some improvements on a plan to improve bus speeds and a case of specific avenue. So the idea when we look at monitoring is to develop tools for system monitoring and identification of improvement opportunities, especially on the bus system. We didn't focus on the train system, but only on the buses. Now, the problem with the transit system, and especially the buses, is that monitoring is very difficult because the system is huge. As Marcela was telling, we have thousands of kilometers of service and hundreds of lines. So the idea was where we can identify points in our service where bus services faced bottlenecks. And what do we understand by a bottleneck? It was a moment along the route where a bus would be traveling quite slowly, and all of a sudden they will speed up. So that would mean that we have there some sort of bottleneck. And if we were able to raise the bottleneck, maybe the speed upstream would be similar to what we have downstream. So we saw this instead of a problem as an opportunity to improve bus services. So that now the question was, where are these bottlenecks and what causes them? And if we think of what are the causes of a bottleneck, they usually relate to one of the following. They're either bottlenecks that may be at bus stops, or at traffic lights or lights on pedestrian crossings, or maybe due to traffic congestion. And they are all different, and they all need to identify them and to clearly realize what you have to do. You need to go to the site and visit them. So we started searching for bottlenecks, and to search for bottlenecks in a smart way, we used automated data, the data that the system is collecting and that Marcela's team was very precisely gathering together into a good way of visualizing what was going on with the bus system. So the methodology was based on the use of GPS data and bus speed profiles for each of the routes. As you can see here, this is a typical scheme of speeds for versus time and distance. This is a specific line where we had 250-meter sections and half an hour rectangles, and each of them have a certain speed. And here you can identify quite easily where your bottlenecks are. It's not that easy, but it gives you very valuable information that you can use. So we use these metrics to identify where the bottlenecks could be, and we have a couple of papers where we explain the specific methodology we follow. So once we have identified the operational bottleneck, you say, well, here we have a certain, for instance, bottleneck where a bus comes at 5 kilometers per hour and all of a sudden it moves into 12. The question now is, how do you quantify the relevance of the bottleneck? So to do this, we identify how many buses would go through this specific point from different services, and sometimes from different directions in the same specific bottleneck, and multiply that also by the load profile, that how many passengers are in each of these buses, so that you identify the number not only of bus hours that are being delayed, but instead of passenger hours. And based on that, you can build this kind of ranking where you have all your intersections in the city automatically generated, where you can tell where the bus passengers are facing more bus hour delays. And of course, you can then go one by one, try to say how you can eliminate the bottleneck, or improve the capacity of the bottleneck, and therefore improve people's experience in buses. So we were able to build this kind of maps, where, for instance, this is the bottlenecks we identified at 6 a.m. in the morning, and these are the bottlenecks at 6:30, and you can see that many of them are in the periphery, then 7 a.m. and so on. And you can see that once the morning peak starts, the bottlenecks are getting closer to the more crowded areas in the city. Important, the bottlenecks are not always at the same time during all the day in the same places. They sometimes shift along the city. So, and then we move into operational improvements. What do we do with this ranking? So the idea was to design and identify these low cost and fast implementation measures that allow us to improve bus operational speed. We generated we called a speed improvement plan with several government institutions to address these opportunities. This was not something that we could do from the academia. We needed them involved. So the idea was to define a certain hour where at a specific time when the bottleneck was more intense, and visited with all the people from the government and the local municipalities, and sometimes the bus operator, to identify the cause and possible intervention for each of the intersections. Then we study the alternatives in a similar way that Oded was mentioning, this step by step, study the alternatives of solution and then select the best one. Here there was sometimes a lot of simulation, and then implement the solution in the streets, and of course monitor the impact of the projects. And I'm going to tell you a little bit, one specific case. For instance, this was the visits we made on a certain semester, and you can see at the bottom here, Gabriela with Ejército Libertador. This was our number 38 in our ranking. So we go there and visit, and this is what we see. And immediately you go there and you realize that the problem is with the traffic signal. And inside you can call the people looking at the traffic signal or in charge of the traffic signals and ask them to change the green light for each of the accesses. And once you do that, immediately you can reduce the delays for the buses without really generating any problem with the conflicting road. So it's very the process was very encouraging because you could realize very easy what to do, and you can see the impact sometimes as fast as this. And we were developing some automated tools where if we could realize that the problem was in the traffic signal, maybe we could even avoid going even there. But that's something we haven't done yet. So in this case, we were able to reduce 4 minutes in the traffic cycle, and that would mean two less few buses in the whole service. The last example is the case of Avenida Santa Rosa. This is the avenue, the second avenue where more buses move along our city. And in this case, we had a very important problem when the buses were reaching the CBD, where the speed was very close to walking distance, and people would drop the bus, get alight from the bus, and start walking to the center. So in this case, and this is a very massive avenue with around 20,000 transit users every day. So we did a plan where we looked for automated inspection, shorter traffic light cycles, segregation with cones, new operational scheme. But the neat thing is that we were able to do step-by-step implementing different actions, and at the end measure the effect of each of them, where we realized that the contribution of each of them at the end allowed us to get a 57% reduction on the travel time in the last segment. The cones didn't work, and so we didn't do it at the end. It makes things worse, but it's also good to realize what works and what doesn't work. So to summarize, and this goes to the end of the talk, and I'm going to be summarizing not only my part but also Marcela's. We were able to identify the worst bottlenecks of the bus system. We can now identify bottlenecks more precisely and quantify their magnitude. Incorporating bus loads to prioritize intersections where more users are affected was better than doing only by buses. The tool identifies location, not causes. So site visits are fundamental, and you need to do that. This is something it's very difficult to do from your office. There are low cost and fast implementation opportunities that can have significant impact on the transit system, and coordination between the different transport institutions is key for success. So this is a very interesting story from Chile, I think, where we have shown that there's a possibility for quantum leap on information availability and cost. And we have many tools that can be developed to improve planning, operation, and control in the different stages, as Marcela was showing at the very beginning, and the application I will show at the end. I think we can advance more on understanding behavior and test our hypotheses. And of course, solid grounds are needed to formulate new and better focused policies based on disaggregated information. At the end of the talk, only for those that are interested, we have added references from both groups so that you can realize what we've done. So thank you very much, and we're really enjoying this session.
Thanks, Juan Carlos and Marcela. A lot of interesting work, and we can already see a lot of similarities with other research centers. There's so much synergy. Well, congratulations really for this impressive scope of work you've been doing over the past decade or so. Next in line, we actually move northward to MIT and Northeastern. So Jinhua is going to give us an overview of the research work they are doing in Boston. Jinhua.
Sure. Right. It was wonderful to see all the 7 labs coming from the different globe to presenting this. And thanks Emma and Brendan for organizing this. So I'm presenting the MIT Northeastern University Joint Trend Lab. The lab is co-directed by Professor Koutsopoulos and myself. Of course, the lab was founded by Professor Nigel Wilson and Fred Saucci. I was the student of the lab, and both are my professors and lifelong mentors. So it's a humbling task to continue this great legacy here. But now I have Harris, so we'll continue as my best research partner to continue this journey. So the first thing I want to share is the cross-cultural learning that I really appreciate as part of the lab, right? We had the luxury of collaborating with several major transit agencies across the globe in a very in-depth way, right? For example, TF Transport for London, been working since 2005 for more than 10 years. Chicago Transit Authority, Boston, Hong Kong, etc. Right. So here you can see the diversity of different agencies, but only after you see the differences, you start to appreciate the commonality that they face. There's a lot of learning that we can facilitate across the different cities and different cultures here. One thing through this process, we kind of identified and developed this innovation pipeline. That's really a collaboration between the agency and the MIT and EU lab here. Particularly at the idea stage is a co-identification of the topic. That's really critical. That makes a lot more research out of this lab be actually relevant and actually utilized in the agency. And then the methodology, of course, is the lab that really advanced in this. And then come to the industrialization and implementation, that's primarily the agency job. But at the end of the cycle, here, that's the important monitoring process that also MIT start to participate together, working with TFL and trigger another cycle of the idea generation here, right? So what can we contribute? There are really three different levels of contribution here. The first one is kind of the short-term specific problems, right? But the second one is develop these long-term platforms and capacities to empower the agencies. And the third one, also want to add, is in many ways, MIT and EU to try to provide a role of a catalyst to trigger institutional changes in many of these agencies, right? So for the first two specific tasks, there's some examples from Hong Kong MTR, looking at during the Occupy Central or South Line opening, look at the impact on the system, the customer, different disruption analysis, etc. Right? Now on the platforms, we develop things like crowding estimation, crowd demand management, predictive analytics. Many of them I'll get into in a second, right? But the third one, I really want to give example of this institutional change. For that, let me use TFL as an example to look at the evolution of the data analytics. Just like most agencies around the world, until 2006, they operate planning operation based on manual survey, right? That time, MIT started to work with TFL, develop this Oyster-centric planning and operation platform, right? And now we're moving to the third phase where we have a multi-modal data fusion. Based on the different level of data, you can look at the different time horizon of analytics, from historical to quasi or real time to predictive, right? And the mapping is more than a one-on-one mapping, the multiple connection there. So look at all this a plethora of different type of data here, right? But not only have to get the data, but also you have to combine it with this statistical data fusion methodology to really bring out the power of this. So for example, corresponding to each of the phases, you can look at different type of application on the planning and policy level, at the control and communication level, or on the proactive decision-making and information customization level, which I will try to give some example here, right? And these are three categories of application we're doing. One of the customer behavior, like how to quantify and inform reliability. On the decision support, for example, during disruption management, and the planning and policy look at, for example, how to integrate the new mobility service like autonomous vehicle, shared mobility with the public transit system here, right? TFL in a way is unique in terms of the organization, right? They have a dedicated TFL analytic team headed by Lawrence Siegel-Weinstein and then the Shashi Verma as the CTO. They really brings this data analytics together and with MIT to help in the process and then drive the innovation in each of the operating arcs on the ground, buses, road, etc. Right? Here, so that's the first part. The second part, I want to give a sense of what I observe as an emerging trend in the mobility industry as a whole, and how much we'll bring some of the thinking into the transit industry specifically, right? I put four things here. I probably only will focus on the first two: the predictive, individualized, being more experimental, and this multimodal integration. Let me start with the first one. This is an example in MTR about this near capacity operation. This is a station in Hong Kong. Not too surprising to see all this level of crowding there. So the first thing we try to help them is it's about this left behind estimation. This is Admiralty station, one of the business stations. You can look at between more than half or even 75% of the passenger cannot board the first train, right? This happens all the time. And they've been using manual survey to collect and report this data. So we help them to using this automatic data develop this estimate engine and use that to drive the estimation. So here is a comparison. It's provide a very high level accuracy, but now without this manual survey. And this process we use to drive both the customer information and the governmental report, right? But here I'm trying to give a sense of how do you move from the retrospective to the predictive analytics here. For example, about this left behind estimation, we're moving from the estimation to the prediction stage. Here's we bring this data, but impose a machine learning predictive engine to predict what not only estimate now, but look at in the next 15 minutes or 30 minutes, what would be the left behind probability and a waiting time corresponding to the customers. Similarly, we've expanded the prediction analytic from the just left behind, but to the broad demand prediction. The task basically is given this historical observation, can you predict the demand at any given station for the next 15 minutes or 30 minutes horizon here, right? So I'll skip the methodology, but this is example from Stratford Station and TfL. You can see that the dotted line is the historical average, while the blue line is the observed. And our prediction engine is able to really track the observed patterns pretty well in this case. And this illustrates the comparison between the historical average versus our prediction, not only reducing the error, but also reducing the variation of the average significantly. Based on that, we're developing a predict and a control engine, bring the prediction side and the control side so that in the end you can export like the expected waiting time or space for new passenger left behind, etc. So therefore, I'll give you one example of the application. In the real-time train information, not only you can say there's 2 minutes a train coming, but we can say this train will probably be very crowded, right? While the train after will be more likely for you to board, right? So this is a kind of a whole platform of moving inference to prediction and to forecast. But next, let me give you one more example. What do I mean by individualization here, right? So here is in the specific sense about the information side. This is a research by Zhao, who is now an assistant professor in Hong Kong University working with Harris and May. About this, can we personalize transit service, right? Give you an example, in the airline industry, if there's something wrong, they send you an individual message about the individual flight. While in transit, we say, oh, the whole southern line is down or something, right? Here, based on one's travel history, can you predict the next trip, the travel time, origin, destination? Any prediction, for example, people have to make a decision, travel or not, at what time, from where to where, right? This is a complex chain of decision-making process. But any prediction based on certain level of regularity, right? So if you can identify the historical pattern, then based on which you can develop it. Here, the particular method we use is the N-gram model here, but the prediction accuracy, we just give the illustration, it varies by the travel time, origin, destination. For origin, for example, next origin in particular, about 80% of the level, and with a variation across the multiple people here, right? So how accurate, how good this is depending on application. For example, you can take the top 10% where you have high confidence of prediction and introducing customer information service, right? So for that, I just to give an example, when service can be more effective when personalized. Here, just give you one particular example in terms of the station crowding, when sometimes they have to close the door, right? So here, instead of broadcast the message to everybody, you can calculate the probability of this event is how much is relevant to a particular person based on the calculation of a travel or not, what time, and at what station, right? So based on this, they can provide a set of customized services based on this individual predictability, and then combine it with a certain recommendation, then you can develop a whole recommendation engine here, right? So that's the few examples I illustrate. The first trend about moving from retrospective to predictive, moving from a mass service and information provision to an individualized service and information provision. Then other things like from static planning process to a more experimental planning process. And the fourth one is on the isolated mode to the multimodal integration. I won't get to this, the last two, but I want to add another set of things I'm thinking of. What's the trend in terms of the understanding of mobility behavior here, right? That's a particular angle we are introducing on the behavior science angle. We'll look at how behavior is actually social, emotional, and perceptual, right? People look at not just travel time, travel costs, but also look at the carbon emission, public health, mobility equity, privacy concerns, etc., right? So that's another area our lab tried to bring this behavior science understanding and the transportation technology understanding, and using the data analytics as the foundation, right? So that's all I have for now. Thank you.
Perfect, exactly on time. Well, thanks a lot, Jinhua. As always, we're very impressed really by the diversity and innovation really of the work that you do at MIT and Northeastern University. It's very exciting. Thanks a lot for sharing those insights with us. Okay, next next we move to Montreal. So Martin Trepanier is going to give us an overview of again the exciting work they are doing over there.
Hello, everybody. So welcome. Thank you for being here today. It's a very nice conference, very well organized. I'm very proud to say that our colleagues from Toronto organized it very well, especially given the circumstances. And I wanted to make this presentation today more focused on how did we start to collaborate and how it can be possible. And I will present some works, but I think that you will see through the conference, through other presentation, more information. So the whereabouts of collaborations. The first thing I will talk about is what is the CIRRELT, which is the research center I'm now the head of. How do we collaborate? And quick example of project and benefits for transit authority. So what is CIRRELT? So CIRRELT is 50 years organization this next year. So the first thing is, where is it? So is in the province of Quebec. As many of you may know, it's a province of Canada. It's a French-speaking province, 8.5 million inhabitants, and most of the people live in the southern part of the province. And the greater Montreal area is about 50% of the population. So starting from this place, there are universities in Quebec. There are at least 15 or 16 universities of all sizes, of all kinds. And the government of Quebec has a program actually who fund what they call strategic groups, and the Inter-University Research Center of Enterprise Networks, Logistics and Transportation, CIRRELT, is one of these strategic groups which exist in many other fields. At this time, CIRRELT, it groups 103 professors from 13 Quebec universities. So virtually everyone in Quebec who work on transportation research is member of the center. It hosts more than 1,000 students, a lot of postdoc fellows, a lot of professionals, but they are not all working on public transit, as you may expect. So research is on logistics, transportation at large, mobility, road safety, healthcare logistics, urban sciences. And the colleagues are from many horizons. So people are from engineering, some are for urban studies, some are from management. So there's a lot of expertise and disciplines that are in the system. So it's very interesting for us. And it's part of IVADO, which is the Artificial Intelligence and Data Science Institute, which is in Montreal with more than 250 professors that focus on AI and optimization problems. So starting from that, what does the research center, what does it do for its members? So CIRRELT is providing tools, rooms, and personnel to enhance the scientific life and activity. So we don't have any research money. We don't give money to do research for the professors. Each professor is independent, can do whatever he wants or she wants. And universities in Quebec are all publicly funded, the same tuition fee for everyone. So money is flowing very easily between universities. So collaboration is the key. That was I would say, the goal of the Quebec government when they started these programs, and we are forced to collaborate. And if you may know Quebec, the province of Quebec is quite small, but every professor that works in this field is trying to collaborate together. So we provide rooms for visitors and meetings, provide support for conference, research, preparation. We have a lot of scholarship, etc., etc. And the main outcome is collaboration. And we have a lot of collaboration, especially around the world also. So how do we collaborate? And so the start of that was the CRT, which was the Transportation Research Center in the 70s. And some companies, like you probably know Giro Software, a company who produces the Hastus software, and also Inro, who produces the ME software, are from Montreal. So Giro is now a very established, solid company. And there was also in the 80s large origin destination surveys in the Montreal area. There still are conducting surveys, a 5% sample, very large survey. There was also a group at Polytechnique which was called Meditoc, who developed software, collaborated with a lot of Quebec transit authorities. There were LRT studies, and for the transit data part, it started more around 2003 with the first collaboration with smart card data with the U.S.A authority. And with the implementation of the smart card system in Montreal in 2009, there were new needs, obviously, coming from that. So there's a lot of professors are in the CIRRELT, but I identified some that are working with transit authorities. As you probably know, Ahmed El-Gennady from McGill, Catherine Morancy, my colleague from Polytechnique, and a lot of others are working with transit authority, and probably others that I'm not aware of, because there are a lot of activities at the center. And the partners, we work virtually with all transit authority of Quebec, the province. So all the cities, the smallest to the largest, especially in the Montreal area. We also work with the Montreal Area Planning Agency, the ARTM, and we have international collaborations as well, especially with Chile, Marcela, and also in France with the region of Paris, and also work with Mark in Australia. So there's a lot of exchange and collaboration. The research topics, the data, around data, there's a lot of them. Well, you see the smart card analysis, which is something much obvious. We also work with maintenance data for, we have colleagues in industrial engineering who works on maintenance, preventive maintenance. We also work on real-time GPS data. We have my colleague Catherine has a research share on mobility, so she works with a lot of partners in this area. We also work in paratransit. We have a research share on transportation transformation, which focuses on GHG emissions. And we also developed the planning tool, the transition planning tool, which regroups 6 transit authorities from Quebec. And we try to get better tools for them. So there's a lot of topics, a lot of areas we're working on. And we virtually have all the data that's needed, the smart card, GTFS, ADL, APC. We have surveys. We have also data on bike sharing, car sharing, taxi, because it's very important, because these modes are complementary to transit. So if we don't have this kind of data, we don't have the overall portrait of the situation and everything, etc. So where does the money come from? That's a good question, because that's how can we initiate collaborations with transit authorities. In Canada, we have a lot of programs, and I'm giving a short list here just to tell you that in your own country, you probably have these kind of programs, and you can maybe take advantage of that. So there are internship scholarships, which is the government pays half of the internships. Collaborative grants, so that can be research grants that can be put on. In Quebec, there's special research funding for some parts like electric vehicles that are from IT programs also. We have research share. We have 5-year agreements with some that bond many TAs together. Specific research contracts, as you may expect in all universities around the world. And also, very important, we have a confidentiality agreement, because the data is very, it's a privacy issue for sure. We have to make sure that all data is kept in good security and everything is taken care of. So a quick example of projects that we're working on. The first one is smart card analysis. So the thing is, we're working on that since almost 17 years now. So we have a long range data, and it helped to develop longitudinal models especially. And we're working a lot of forecasting models, user behavior evolution, especially clustering with categories of user on all kinds of all things. This is just an example here. The figure shows that over 5 years, how many users remain in the same category or the same segmentation group. And we also mix data with other sources, bike sharing, car sharing, taxi. So this is something that we're working on at this time. We're still working on this. The other thing is transition. Transition is an advanced planning tool. There's a need in the transit authority to be able to plan the networks, especially the geometry of network, the operation, scheduling, and looking at very detailed demand data. And what is key in transit, as you may know, is that the access. So access is done by walk, by bike, by other modes. So transition uses a very detailed walking network. Everything is coded. It uses OpenStreetMap. So there's a lot of information that are within the system. So it's an open source approach. At this time, it's in development, but the platform will be available on open source as soon as we may release some of the features that are working and are working well. The other one is I was saying that we are part of AI group in Montreal, and we use advanced AI methods in data analysis, and all techniques are used. So we use it for anomaly detection, fine-tuning, data fusion, forecasting, and there's a need to integrate the transportation dimensions into these methods. The AI techniques are there since many years, but now we try to add some spatial temporal clustering, spatial temporal dimension to this kind of data, which would enhance them. So what is the benefit for transit authorities? The first one is tool development. So in this group, we develop tools, we develop processing algorithm, demand modeling, and we can share them with the transit authority. Obviously, there's an issue, there's a problem with the implementation, but this is another question, I would say. Innovation and highly qualified personnel. I think this is the most important result. TAs are hiring students that work in the research project. Almost all the planners from the Montreal TAs were trained at the CIRRELT, and this includes a PhD. So this is our very most valuable asset to be able to continue this collaboration. So I thank you very much for attending, and I will feel free to ask any questions if you like.
Thanks a lot. That's so much, very impressive. Thanks, Martin. Last but not least, we move down to Ohio. Mark McCord is going to give us an overview of their lab and the work they do in Ohio.
Whoops. There we go. Good morning, everyone from Columbus, Ohio. Rabia Mishlani and I are happy. We appreciate the opportunity to be able to tell you about the living lab we've developed at The Ohio State University for transit research, education, and outreach. We find, start my video. Okay, sorry. Is that working now? Am I on?
Yes, you are.
You're good. Sorry, okay. So, Rabia and I find the history of the Transit Lab fairly interesting, but today I'll simply mention that it's developed over the past 25 years and it's still developing today. The Campus Transit Lab, CTL as we call it, is based on the OSU, Ohio State University community and its campus area bus service. The Ohio State University campus is one of the largest single site campuses in the world, both in terms of contiguous area and in terms of on-campus population. In addition, it hosts multiple and diverse land uses. It has a large medical center, a large central campus, an agricultural campus, athletic campus. It uses major arterials, local streets, has freeways passing through it, and importantly, there's a large commuting population, so there are several large park and ride facilities. The campus area bus service, or CABS as we call it, is the backbone of travel in and around campus. It carries over 5 million passengers per year on 6 overlapping routes. All the buses are equipped with APC and AVL. We in the lab get daily downloads of these data. We get them every night, and it's the raw data, not processed data. Riding is free, so there is no AFC data, which is one drawback. It's good for the users that they don't have to pay, but we don't get AFC data. So we believe sort of the size of the campus, yet it's contiguous and small enough that we can get around, makes it manageable. And the CAB system makes this representative of a small urban area. And so we like to say it's realistic, but it's also manageable because we can get around it. And that's what we like to talk about, the proximity, familiarity, and accessibility. We have a bus stop just outside our door, and this allows, with easy access to the campus, students can go out and collect data in between classes rather than have to go to a remote site and spend time traveling to and from, which would therefore require intermittent data collection. We have ongoing sort of regular data collection. Students live in the dorms. Some of them use the park and ride facilities. They're out and about campus. They're familiar with the travel patterns. Being familiar with the travel patterns in this manageable system makes interpretation of the research and outreach results a lot easier for investigators. It also makes use of the lab in our education much more relatable to the students. The institutional accessibility is something we like to talk about. We've developed good relations with the managers of the bus system and overall transportation system on campus over the past 25 years. We meet with top management every 2 months and with the operational service providers every month. And these relations have allowed us accessibility to the system that would be hard to get otherwise. We put students on the bus to collect boarding to alighting surveys on a regular basis, multiple trips per week with no red tape. We've been allowed to carry Wi-Fi sniffers on the bus. We've drilled holes in the top of the bus to carry air quality sensors. We get regular access to the video data. This is video cameras which they've installed for safety and security reasons. We use the video data for traffic studies. In addition, in fact, I should say, when they were implementing these video cameras, they worked with us on this rear driver's side camera so that we could get good angles of the traffic for our research studies. Again, this is because of what we like to call the institutional accessibility of the system. As researchers, we have access to large groups of faculty, staff, students for web-based surveys with IRB approval, of course. We like to say that our research is empirical research that's conducted in the regular transit operations of the systems. And we conduct this research to gain insights and validate methods in this confined setting, but we do these studies that we believe would be of more generalizable interest. So for example, here we're indicating our estimation of OD flows from APC data, from the boarding and alighting data. We develop methods but to sort of get better estimates, but probably just as interestingly, this ability to collect ground truth, B to A, boarding to alighting data on a regular basis, which we've done over the years, has given us access to a large validation set for these OD estimation techniques. We like to think that what the things we do on campus are a springboard to sort of more, to larger agencies. This is an example of a study we conducted for the Ohio Department of Transportation, who was interested in using these OD estimation techniques from automatically collected data to reduce the need for deploying manual data collectors to expand onboard travel surveys. This is another example of a study we've done where we've tried to reduce the size of the OD table by grouping contiguous stops in such a way that we retain the structure of the OD flows in the table. Again, our familiarity with campus travel patterns allowed us to interpret the results of the algorithmic results and have faith in them before we applied it to larger agencies like the Central Ohio Transit Authority or LA Metro. I mentioned that we like to survey people when we can. This is an example of a study we conducted that showed a before and after survey, before and after implementing the real-time passenger information system on campus. And the study was designed for several purposes, but one of the results I show here, or emphasize here, is the fact that this real-time information system, at least it had a statistical association with positive attitudes towards transit's its role in environmental sustainability and traffic reduction. And this role was both for users and non-users alike. This is of interest academically, but we think it's sort of important for transit agencies that rely on political support for maintaining a viable system. For something completely different in terms of research, we like to think of using the bus platform as a mobile sensor for a variety of purposes. Yesterday, I talked about our use of the sensor of the platform to carry an air quality sensor. Here I'm illustrating our use of the video cameras to capture pictures of traffic, and from repeated observations of the traffic, we can come up with flow estimates on links that would otherwise be unmonitored or very infrequently monitored. Rabia and I would be happy to talk about many other examples of research offline, but I'll just skip now to the educational component, which we think is very interesting and kind of unique. In addition to supporting graduate theses and research and giving our graduate students and undergraduate students getting their hands dirty with regular data collection, we bring the lab infrastructure, the data, and just the setting into classroom. We use it regularly in 2 mixed undergraduate graduate elective transportation courses, and the 1 required transportation course of all civil engineering undergraduate students. In these 3 courses, we see about 200 students per year. I won't talk about the modules or the assignments or the term projects we do, but I will just mention in the undergraduate class, I regularly ask on the final exam of the 10 or so modules we cover in the class, what's your favorite and tell us why. The lab-based module, it typically is the most preferred, along with the geometric design module, which seems to appeal to undergraduate students who are required to take a transportation class. But the students who talk about the lab module talk about the ability to interpret empirical results with the methods they've learned because of their familiarity with the system. The transit managers are often talk about their sort of pride, I guess you could say, in the research and educational aspects of the lab because they want to be associated with these important missions of a large research university. But I think it's the outreach products that keep us in business. We're not consultants, but we're happy to do sort of one-off studies for them that rely on our expertise or the algorithms or data we've developed. I won't talk about those, but I'll just briefly mention some of the regular products we provide. We provide monthly origin destination flow information using our estimation techniques. We do these for the different routes, the different time of day periods. The managers say that they don't have any other access to this, so they definitely appreciate our ability to do that. I won't talk about the details, but there's a politically sensitive route where frequency of service is a hot button political item right now. We use the AVL data to give statistics on headways on this route and provide these on a regular basis. The managers have told us they use these in their public presentations and their private discussions with upper university policymakers. We have several other monthly products we develop, which I think keeps us in business, but I won't talk about those here. We're always interested in developing new products or embellishing existing ones. Again, we have several in the works. I'll simply mention one that came out of a study by a large automaker who wanted to take advantage again of the size of the campus to investigate possible mass opportunities on campus. As part of this study, it wasn't the whole study, as part of this study, we merged our transit ODs with data that we collected in amassed for bike sharing, scooters, on-campus automobile traveling, and other special transit services to give the first ever at OSU, multimodal origin to destination flows by time of day. We're looking for a way to update these on a regular basis now that the project's ended, but these are the outreach products we're kind of thinking about. So in summary, the size of the system but its manageability, along with what we call the proximity, familiarity, and accessibility, we think makes the campus transit lab a unique setting for focused transit research, education, and outreach. And I appreciate your listening to us today. Thank you.
Okay, well, thank you so much. It's been a fascinating tour of all your labs. Can definitely see a lot of similarities between the labs, but also some uniqueness in the way each lab really manages its research partnerships and collaborations. We have about 7 minutes left, so I would like to take this chance to start a discussion. I know there have been a number of questions that were already answered. But one thing that I wanted actually to put out to you is we see a lot of collaboration going on, which I would characterize mainly as local or regional. There are, of course, some examples of international collaboration, but I wanted to ask your view on best practices of center-to-center collaboration. So we have 7 centers here that are doing amazing work. I think there is so much opportunity to even bring some of the synergy between the different centers, and if we can foster this center-to-center collaboration. So I just wanted to hear your opinions on this.
I'm here, Martin. I think that the best way to collaborate between each other is through students and interns. I think that obviously, because we cannot share data. I cannot share my data, send my data to Marcela, or Marcela cannot send her data. So the best way is to take a student, can be a short intern, send him or send her to the place, and then can start to work, apply methods, try to develop something together. And this, I think it's a good start. It's something that goes between between profs. And we have opportunities of international collaboration. So we just started one with China, which we have some research funding for that, but it's quite hard. So that I think it's easier for us to go through students. Maybe that's a way.
That's a good thought. Any other opinions from the panel?
I totally agree with Martin because it has worked well for us. I think it's easy and great for students, especially PhD students that can spend perhaps 1 year in another country visiting another university. So I think that's something we should go for.
Yeah, another alternative is, again, building on the idea of students, is to use our transit data community and platform to maybe develop some sort of summer school or place where we can all gather like we're doing now. I mean, this has opened so many possibilities where we can bring different realities. I think this session has been wonderful in terms of showing the diversity of work we can do and how similar it is on the other hand too. The same, we're dealing with the same problems, but sometimes with different approaches. And I think a summer school where we could all, instead of compete, as universities usually do, collaborate together so that we can bring the idea that transit systems should perform much better to really contribute to urban sustainability. I think that would be very valuable from us as a community.
Yeah, those are definitely great ideas. Yeah, student exchange and summer school are indeed the way to start. I see one question addressed to Martin. Do you find that there are significant differences in public transport perspectives between the French and English-speaking universities in Quebec?
That's a good question, because what I said is that every university in Quebec is publicly funded with the same tuition fee. So even McGill, Concordia is like Polytechnic University. There's absolutely no difference, and it's an enrichment because in the English side, there's more students from English-speaking countries. For obviously, we also have English-speaking student, but it opens. It's a way of collaborating. It's just that we don't mind about institution. I know that institutions are in competition, and it's not different in Quebec, but we just, when we have a project, we get the best people on it. So I'm head of the CIRRELT. If a TA come to me and say, I wouldn't work on that, so I'm thinking, okay, I have 25, 30 professors. I can say, okay, this person, and I ask, and we get the best team we have. And after that, we ask question, okay, where the student will be, because the student has to be somewhere. So if the students is in McGill, the money will go to McGill. If the students is at Polytechnic, it will come to Polytechnic. So there's no, I think that there's not much difference. I think that it can be interesting also for people, our colleagues from McGill and Concordia, especially because if we work with Quebec Transit Authority, it's mostly in French, but it can be interesting for us also. Like Lee Jun-sun is a very good guy, just coming at McGill, and he's a lot of projects. He's there since 2 years now, and he's doing a lot of project with us, so it's very, very interesting.
I have another question generally about when you develop some new technology, let's say a new software solution or something, what's really the best practices in terms of transferring this technology to your private partner? There could be, like in our university, there's a lot of bureaucracy that one has to go through, which might sometimes delay really the transfer of the solution in a timely fashion to the industrial partner. So I just wanted to hear your experiences on that.
Yeah, I can add a little bit to that question. So throughout the years of collaborating with Chicago or London or MBTA, etc., we did kind of try to explore a pathway for the knowledge to be disseminated, right? I think there are two level discussion. One is at the technical level, right? That's like a software architecture, using open source softwares, using the software that the particular agency can take into, right? Particularly, they often have an internal net that their staff using, how to get into that, right? How to coordinate with their IT department, right? The second one is actually more at the personnel level. That's in the sense of the agency need to have the attitude of developing their internal capacity, right? So for example, we often have a buddy system. We have a researcher at MIT or NEU, and then we have a buddy within the agency who talk to each other on a much more frequent basis, right? So we as a whole report to them maybe 3 times a year, but they may meet at a weekly basis, right? So have the local staff really understand the data and to some degree the methodology, right? As the students work on it, right? And then this staff will be the owner of this project after we finish the method part, and the staff will then continue on, right? In the end of the day, I think we have to help the agency build up their capacity, then we just try to push the ideas to them.
Yeah, I think that's important. Of course, with our confined campus, it's a little easier, but I think, Jinhua, what you mentioned, we meet regularly on a regular basis, face-to-face with the managers and with the operators, so they know what we're doing. It's not like we get an idea, we go away, we finish it and try to give it to them. We're meeting with them regularly, telling them the results. The fact that we deliver them products every month, I think that they use is helpful. And a lot of the things we develop come out of our meetings. And it's not just an academic idea that we have, but it's something that's appealing to academics, but it comes out of the actual discussions of the needs they have to run their system. That's a little harder to do with agencies that are far-flung across a province or the country, of course.
If I can add something, I think it has been very important also that the students that participate in those projects, they then go to work in either the transit authority or the operator, and that's crucial. That's really very important to make it possible for them to appropriate this knowledge and use it further.
If I may share another challenge from my experience is that with the exception of maybe the very large transit agencies internationally, others are also, they don't have direct access to the software. They're end clients, and oftentimes for them that's a black box. So we had several times the experience where when you actually want to move forward with, for example, implementing different underlying algorithms, we have to work also with a software provider. And for them to make such changes, of course, there need to be sufficient demand, or this client has to be sufficiently important for them to take such an action. It may not be sufficient just to work with the operator in such cases.
Yeah, well, thanks a lot for your useful insights. We have one last question. Unfortunately, we're actually above the time, but one last question. How easy is it to build student transit agency collaboration and knowledge transfer? And what is needed at the supplier, which is the university, and user, which is the agency, to make this work well? So how do we facilitate the student and transit agency collaboration knowledge?
Like I said, I think there's many countries that there's program for internships. So this is the best way. The students works for the authority, is half paid by government, half paid by the authority, and he works or she works on a research project, which involve data and people from authority. So I think it's a win-to-win situation.
One thing, I guess, is the mutual understanding. Because the agency and academia, they do have a very different objectives, right? So when we sit down, talk to each other, for example, we try to inform our collaborators, say that in the end of the day, if you have say a project you need in 3 months, right? We cannot help you on that, right? We need to develop a methodological contribution, often in the cycle of 1 year or 2 years. It has to be deep, right? At the same time, I think as academics, we also have to appreciate where the sponsors, right? They cannot support you only for you to write a paper in TRPC. They need something to be useful here, right? That's the part where I say at the idea generation stage, for the two parties to work together at the first stage, that's important, right? So that at the very beginning, make sure this is of relevance to the practice, but also you can claim a methodological contribution, right? If you start with that, that's much more likely in the end that's something meaningful for the agency.
Well, I would have loved to continue the discussion, but unfortunately we're a few minutes above our time. It's been very informative. Well, thanks a lot, really, on behalf of the organizing committee and also all attendants. I extend our thanks to all of you. Thank you very much, and enjoy the rest of the symposium. Thank you.
Thank you, Emma.
Bye.
Hi, everyone. I'm going to jump in real quick as your friendly administrator here with a quick note. So we'll be starting the next sessions very shortly, but we are having a small security, like it's not a security issue, a certificate issue with the website. So if you're getting an error saying that it's not granting you access, you can proceed through. It's fine. It's totally safe. And we are also planning to send out a PDF with the links in it as backup. So if you're having trouble accessing it, just keep checking your email and keep trying to get into the page. Otherwise, we'll see you in just under 10 minutes. Thank you.
Thank you.
Bye.